Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and with me today is another colleague from the state of Missouri, coming from Missouri State University. It's my friend Patrick Sullivan. Patrick, thanks for being here.
So excited to be here. Thanks for inviting me, Sam.
We're going to be talking about a book that Patrick wrote called See It, Say It, Symbolize It, Teaching the Big Ideas in Elementary Mathematics. And it was really fun to read it, but I know you're not just an elementary guy. You actually have come from a lot of different grade levels.
Yeah, my background is actually in 9-12 mathematics, secondary education, and it wasn't until I came to Missouri State in 2014 that I actually got involved in elementary education. They had me teach a couple classes, and I'm like, wow, this is interesting.
Well, so that's still a decade living in the elementary math
Yes.
world, which is, it comes through nicely in the book. So we're going to dig into that book in a moment. But first, let's just back up. This is the first time I've had you on the podcast, even though we've been friends around Missouri here for a while. But let's go back to your grad school experience. Where did you do grad school? I believe you're a Big Ten guy like myself.
I went to Penn State. I was part of the Mid-Atlantic Center for Teaching and Learning started in 2002. My advisor was Dr. Kathleen Hyde, who just recently passed away.
Yeah.
And she pushed me. She was definitely my academic mother, and Rosa Bick as well played a huge role in getting me to the finish line on my dissertation. And I took a long road to get there. I was a graduate student for 5 years. I had some things going on in my personal life and felt like I needed to take a break, and helped a friend start a private school, and then finished in 2012. So I was on the decade plan.
Okay.
But we got there, and I'm thankful for that. Had that opportunity, and just the folks, some of my closest friends are still the colleagues and folks I met at Penn State.
Yeah, great. And we got to hang out at Penn State at PMUNA.
We did. I got to have some ice cream at the creamery. Highly recommended.
Yeah. So with your dissertation, what was the focus back then?
It was characterizing the feature noticing and feature utilizing of students with different algebra exposure. And so we just looked at how students made sense of symbols, taking problems that you don't procedurally think. You have a procedure for example, the absolute value of x minus 1 equals absolute value of x plus 2. You think all of a sudden you see that, you dig in and procedurally, but if you just analyze and think, well, what's the distance between 1 and negative 2? What's a number that's the same distance? Mm-hmm. So, and then we can also think about the graphical representations of that as well to solve. So that's really what it started out as, was really being able to, I've been interested for a long time in what do we actually see when we look through symbols? And so that was kind of the genesis of that idea a long time. What's been almost 10, 12 years ago now.
Wow. And then I think that careful thinking about symbols and how students interact with and make sense of symbols is something that carries through to this book as well.
Absolutely.
Yeah.
Absolutely.
Which I think is a big thing in math, of course. Like we've got symbols flying around all the time. Students are pushing them around, and what's actually happening? What are they thinking about when they're doing that?
Exactly.
Yeah.
Exactly.
So that maybe sets us up then for getting into the book. See It, Say It, Symbolize It from Solution Tree. See It, Say It, Symbolize It becomes kind of the mantra of the book. It helps kind of be a guiding framework. So just help us understand, what do you mean when you say see it, say it, symbolize it? What are you thinking about there?
Just this idea that, when we look at representations, there's a little bit of a link to concrete, pictorial, abstract, but it's not just having the picture. It's being intentional about what that picture is or what that representation is. And it can come from two directions. It can come from us, or it could come from a problem where they've represented something, but there's a language involved in it. That's why I always felt like the concrete, pictorial, abstract was missing, is how do we communicate? Mm-hmm. How do we talk about what we're actually seeing? So there's a language involved in that. And then the symbolize it part is the last aspect of it, where we're representing this idea with symbols, with mathematical symbols. And so in the end, it's really about, too, when we see, for example, the example I gave earlier in secondary mathematics, when we talk about like the absolute value of x minus 3 equals 2, what do we actually see? Do we see this representation, the shape of the absolute value of x minus 3, and then we have a horizontal line that comes through? Are we able to visualize it that way? Do we see it as being a distance? What two numbers have a distance of 2 from 3?
Yeah. Do
we have a language that's associated with that?
Yeah, well, I think, too, this bigger idea that's brought up is that hopefully people are visualizing something. I mean, it might just be in their mind, right. But that whole point that when we're writing down mathematical things, you can actually have a mental image. You can have a mental sort of way of thinking about it. It's not just pushing around the numbers and getting the numbers out.
Right, absolutely.
So the first step is there should be something going on in your head that you're kind of helping you visualize and make an image of what's going on.
You hope so.
Yeah,
you know.
But then realizing actually for a lot of students, they're going through math and it's just dark up there.
It is.
They're just pushing things around and hoping they're getting the answer.
Yeah, we find that especially too with fractions, that many of them look at a fraction, they can create the image, but they're not really thinking as in terms of numbers as a quantity and a size of unit, which I talk a lot about. What they see is two numbers. 1 and 3.
Yeah.
And so they're thinking 1 out of 3 as opposed to 5/3, for example, is 5 groups of 1/3, where we're really fixing on a quantity, I call it the 5, and then the size of a unit, which is a unit fraction, 1/3.
Yeah. So maybe take us through the see it, say it, symbolize it with the fractions, because that is a big part of the book. So when you see a fraction, what do you see?
Yeah.
Is there an image that comes with it? And then how do you say it? Because you have a pretty strong position on how to talk about fractions.
Yeah, it's born out of just the experience working with a lot of adult learners and how they're seeing it. And so, one of the problems that struck me, and again, this is one of my colleagues' probably thesis years ago, Miss Joanne Barnett, and seeing so many students, believe, like these are 5th grade students that we were in a classroom where we gave them a contextual problem involving 5, 6, and 7 eighths. And we had a large portion of the class say that in fact, one class, it was they all moved their chairs back and stood up, that 5, 6, and 7 eighths were equal. And I'm like, oh, this is...
Because they're both one piece off.
They're one piece off.
One away from the whole.
Yeah, one away from the whole. And we're not thinking about... They could draw the pictures to model those situations, but they're not seeing the fact that missing piece isn't just 1, but it's 1/6 or 1/8. And so the idea was, and I think that happens with a lot of what I call missing piece area models.
Yeah, I was going to say what they're seeing is they're seeing a missing piece.
Yeah.
Like there's most of the pieces are shaded in and there's one that's not shaded in. Yeah. So that's equal. 5/6 is equal to 7/8.
Exactly. And that's what's a lot of the elementary mathematics curriculum start out with those missing piece area models. And so we've really tried to talk about being more focused on what type of models are we putting in front of students to get the thinking that we desire. So I talked a lot about even the number line in the book, that number lines are very abstract. When we put that point down, we're referring to a location, but in reality, that location is based on a length or a distance. And so how do we make that explicit? So I talk a lot about what is called a bar number line model. So essentially we're using sentence strips or Cuisenaire rods, but we're not just modeling with the rods. We're putting them on a number line as well to make that connection between the two so that students can see the relationships. And then so that's the see it part. And then again, one of the things I love about the Cuisenaire rods as well is we can talk about, or sentence stems, I use that too, but this idea of iterating the unit fraction. So we we understand that 5ths and 6ths and 8ths, again, using the morpheme THS, that is partitioning into equal lengths. It's right there. The number of times tells us at the front part of that, how we say that. So again, we do the partitioning and to find that what that unit is. And then the iteration is, once we find the unit, we can talk about the fact that, for example, 3/5 is 3 groups of 1/5, or we can see that as 3 iterations of 1/5.
3/5. It's actually 3/5.
Yes.
So the way you're saying it, you're trying to match it to the picture and have it all kind of click together.
Exactly. And so that's the image we want. And Maria Stewart, former doctoral student here at Oklahoma State, and myself are doing a study right now in our pre-service classes. And one of the comments has come out of was really resonating is the students through the class feel like they have a language now to talk about comparing fractions, even using the words the quantity and the size of the unit that they didn't have before. And so it's completely
not numerator denominator.
We're staying away from those words.
I mean, later you can make the connection,
yeah,
but that's not your main way of saying it.
Yeah, and with adult learners, they already know they have a connection
denominator.
numerator and denominator, but it's the number on top and the number on bottom.
Right.
That's what many of them will say.
Yeah.
And so now we've kind of moved that along, and especially we just came up on, again, completing a semester of piloting this in our pre-service class. And, one of my comments about going back is, well, I need to talk more about 3/5 as 3 groups of 1/5. And you keep using the groups of language because it is a multiplicative relationship.
Yeah. 3 times 1/5.
So, and that's been helpful to students to talk about it that way.
Yeah. And then the symbolize it. So maybe just quick comment about the symbolize it, and then we'll go into the book.
The symbolize it, and again, this is something I feel pretty strongly about, is at least early on, with whole numbers, the numeral has always represented a quantity, and a place value has hidden the unit. But we understand, like when we say 500, we mean 5 hundreds because we understand the place value. Sometimes that's hidden, but it's there. But with fractions, when we go to fractions, if the 5 is in the numerator, it's what we call quantity. But if it's in the denominator, it's a unit. So we've done all this work with whole numbers where the numeral has always represented a quantity. And now we jump to fractions and it depends. So really focusing on using the word label to write out the unit to start with fractions. So initially, we want the struggle bus to be about fifths. Let's talk about what fifths are.
Yes.
And then students do not make the mistake of multiplying numerators and denominators when they're adding fractions.
No, so you have the symbolizing it. They're actually, so let's take the 5/6.
Yeah.
If I shift it back to the 6.
Yeah.
You have in the symbolize it phase, you actually have write down the numeral 5, but then the word sixths.
6. Yes.
So now it looks different. I mean, well, it looks like the numbers you've had before, like 5 apples, and we've had whatever.
Yes.
And you're kind of following that same thing of 5, what is it? 5 sixths, but writing out the sixths before you just stack them. Like stacking them over a bar might come later.
Exactly.
Right?
Yeah. But just trying to get used to the language first, because one of the interesting things that I found working with fourth graders too last year was when I said to a student, could you show me what 5/6 would look like? Well, they drew a 5x6 rectangle because they were hearing 5 sixes.
Oh.
And so they weren't picking up on the fact that a sixth and sixes is something different. So really pushing on the language has been helpful in thinking about that.
Yeah. We're going to get into the book here too, and I will admit the fraction part was my favorite part of the book. And I think if somebody really wants to dig into fractions and wants to help students be more successful at fractions, this book will really do that. But you have more than fractions in the book, so we'll get into some more of that stuff later.
Okay.
But first, you have the see it, say it, symbolize it kind of framework. How did that come into a book form? How did this kind of happen with Solution Tree?
That's a good question. The book was born out of some experience with adult learners, and COVID, was difficult for many reasons, but we couldn't go out into the classrooms and do practicums. So I said, just give me a lower level class and I'll have my pre-service teachers, we'll teach it together. And so I got an email from a student 3 weeks before the class started. It says, this is the third time taking the class. I've always struggled with numbers. And so I just started thinking if I wanted someone who is unsuccessful with school to have an appreciation, start to rewire their brain related to numbers and operations, because again, that's the foundation.
Yeah.
What would I do? And so I started to think through the lens, that idea, and I just started writing the book. I just started writing chapters of what this would look like, and I was thinking about what's the most amount of connections I can make with all the topics in elementary math, things that I saw as isolated. Like, for example, with whole numbers, we would used to be carrying the 1, but now recomposing or decomposing, and then getting a common denominator, and then lining up decimals, for addition. I'm thinking, well, all those ideas have the same idea. They have this idea that we're just combining quantities of the same size of unit. So let's make that explicit.
Yeah, equal exchange becomes a big theme in the book.
Yeah, 1 10 is the same as 10 ones, and there's this relationship that happens throughout, as one example of equal exchange. But just started to think about, how can we do this differently? How can I think about elementary mathematics differently? If I was helping others, how do I think about it differently? And so I just started going through those mental activities of doing that and thinking about, how would I represent it to really help somebody? If I had a small amount of time, what would be the way I'd represent this in the most efficient way possible? And what language would I use? And then, like with adult learners, I'll talk a little bit about this later, but with adult learners, they have to feel that something's different. If you jump them back through the same hoops before, they resent it. Right. They're not naive to the fact that, you're calling me dumb because I'm doing third grade math. And so you have to give them a different experience. And so that's what I thought a lot about as I wrote this book. And, and it initially started out as connecting the dots, or trying to make connections in some way. And then the editor at one point, and this is after, the backstory and all this, is didn't really know how the publishing world worked. And my wife, I'm almost stubborn sometimes, says, why don't you send a chapter to Jenny Bay Williams, and maybe she'll have the time. I said, she's too busy. She doesn't have the time.
Another Mizzou connection, though.
Anybody that knows Jenny, exactly. Anybody that knows Jenny, of course she read it. And she says, well, it just so happens we're working on this series called Growing the Mathematician in Every Child. So would you be interested in being the 3-5 book? And I'm like, absolutely, sign me up. And so we went through some iterations to get a publisher, but then we latched on to Solution Tree. And then it was actually the editor, Amy Rubenstein, who said, why don't you just frame it around say it, symbolize. It seems to be the theme of what you're talking about. And it's a catchy slogan, so let's go with it. And so, still thinking through that lens, but that was the creation. That was the genesis of it.
Yeah. My next question I want to ask, just to give a little more of an overview of the book, what people will find inside this book when they look at it. So they're getting some flavors of it already. One thing I will say that people will find in the book is a few of these big ideas that kind of connect across.
Yes.
So equal exchanges is not just a one-off little comment that you make. You sort of show like equal exchanges can actually make sense of a lot of things in elementary number. I would say one thing they'll find is some big ideas that really cut across the grades.
Absolutely.
But what would you say are the things that people would find in the book? And I know it's beyond fractions too. It's not just fractions.
I've kind of merged this to think about. I mean, we cover the 4 operations and then also get into proportional reasoning. But I talk about 5 superpower understandings. And one of the first superpower understanding is a number is a tethering of a quantity in a size of unit. And I feel like that extends all the way up the food chain. 500s, when we say 5, and there's flexibility in that. When we write out the numerals 500, it's 500s. It could be 50 tens if we want to look at it that way, 500 ones, 5,000 tenths, etc. And so there's all these ways, and we can break it up into multiple units. I always argue, we can think of any number as being a mixed number if we want to, because then we're just using multiple units. So just that idea of thinking through that, and again, it transcends up to how we think about fractions. It also, obviously decimals, and then even into algebra. How do we see 5? If we say 5 tenths, how is that different or similar to when we say 5x? Where 5 is a quantity and x is we can think of x as being an unknown length. And so we can that idea can spiral up, but it also provides the flexibility to be fluent and flexible with numbers and operations down the road, because we, as you and I talked a few months ago, we break apart things all the time. That's one of the big themes of math. And so that fluent and flexible sense of number is the ability to, how can we break those things apart and have the same amount? So that's one of the big ones. And then equal exchange, as we talked a little bit about, that carrying the one, again, back in the day, 10 ones is equal to 1 10, and we do that all the time with money. And so not that we use money much anymore, but that seemed to be a good tangible sense of exchanging quantities of denominations. And so that seemed to fit. And then
I like exchange because it's more what's happening with the quantities, whereas carry is just what's happening with what you're writing on the algorithm. It's
fascinating to me the number of adult learners who will say, okay, I just carry the 1. And I said, well, what are you actually doing when you do that? And they don't know. But then we start talking about it. It's like, oh, well, that makes sense to what I did. We just didn't make that explicit with the language. And so that's the second one, was the equal exchange. And again, obviously it's underpinned by equivalence, but and then the idea of the unit fraction that we talked about earlier, that's another superpower understanding. And then let's see, the fourth one I liked a lot was what I'm calling analogous problems. And so, like, let's go 8 times 5 is 40, which we talk, okay, what's the 4 represent? 4 tens, but we can think about that, and 8 times 0.5 or 5 tenths, 8 times 500, 8 times 5 hundredths, whatever it is. But the idea is that we are acting on, we have the same quantities, we are performing the same actions, but on different size of units. So, like, again, another example, from division, we can do the whole number problem 9 divided by 4. And we can think about it in terms of a measurement, how many groups of 4 can we make from 9? But then we're doing a similar idea when we think about 3/4 divided by 1/3. If we think about it from obtaining the same size unit, how many groups of 4/12 are in 9/12? Again, it's the same way. And it's, my grandmother told me this story when I was a child, it was funny, but how do you catch a unique rabbit? Well, you unique up on it. And then how do you catch a tame rabbit? Tame way. So I think of analogous problems when I joke with my students about it. And when I know I have them during class when they're saying, it's a tame way. I got them. They're totally locked in. But the number of students that have come to me and just said, I now see math is connected when I saw it as very isolated. That's a huge theme that's come out from the book. And what's interesting is I wasn't teaching the elementary pre-service teachers with the book until this year again. I'd taken like a 5-year hiatus.
Oh, wow.
So a lot of the ideas were stemming from adult learners. And now this semester I've gone back and I'm applying it back to the elementary pre-service teachers. And really positive reviews from this semester. They're feeling like, I feel like I'm a math person now. Those are the lines that give me hope that we're going in the right direction here.
Nice. So I wanted to ask too about some of your favorite mathematical nuggets that are in the book. I mentioned before, for me, it was a lot of the fraction stuff that I really appreciated. But are there some where you're like, oh, I'm so proud that that's in there and it brings a nice little math flavor to it?
I got to admit, I'm honest, but you have to get to the end of the book to read it. But, it's, what do frog legs have to do with ratios? And when they let me keep the frog legs line, I mean, I'm sold, but it speaks to this idea that what we think is happening, like my grandmother tricked me into thinking that those were chicken wings. And my grandmother got me to eat interesting things because she tricked me into that. And frog legs was one of those. And so, I think about fractions, they may look and taste like something, but they can be something else very quickly depending on the context. And so that's part of the story between that. But I was really proud of how really thought about fractions, like you talked about that chapter. I really, my heart goes out to students who really struggle with fractions. And, it's joking in the airport. That's the number one topic I always hear when I talk to adults. What did you struggle with? Well, it's fractions. And it's the F word of elementary mathematics in my book. That ended up being the title of the chapter. But I just was, what I'm most proud of is the letters and the notes that I'm getting from students and people that have read the book that says, I had a teacher a couple of weeks ago send me a note that said, for years, I've avoided teaching decimals because I didn't understand them. And this book has now given me the language. I feel empowered. And so those are the stories that come out, and other multiple teachers have talked about, I'm not scared to teach fractions anymore, or I see connections that I never would have imagined. And, the whole day was an aha moment when I've done workshops. And I'm like, that gives me hope, because it's not about the book for me. It's about, are we being able to keep more students in the math game, I call it. Yeah. And so that's the joy for me, to help teachers and students.
Mentioning decimals reminded me of a nice moment. I thought there's a comparison, which, first of all, by the way, I like your emphasis on comparing. It doesn't always have to be compute a number or calculate a thing. You can just compare numbers, and that can bring out a lot of good ideas.
Which is what we do when we have more than one number. We're comparing them in some way.
Yeah, you sort of show like lots of fruitful concept development can come from comparing things a lot and getting into nuances of those and stuff. So it doesn't always have to be computing. It can be comparing. Right. But one of the comparisons was like, I won't get it exactly, but like 0.85 and 0.243.
Yeah, and that was from an innate problem.
Okay, and that's roughly the
ballpark-ish.
But just like, so for us, the 0.85, as soon as you have the 8/10, you're like, oh, well, that's way bigger than the 2/10, and you're done. But for the students, it's looking like an 85, and it's looking like a 200, blah, blah, blah. And so, of course, the 200 is bigger than the 80.
Exactly. Yeah. And that's, again, that was born out of work with adult learners, where I gave them a 3-digit whole number addition problem, like 385 plus 283. They could talk about the units, and they did the work, and we could talk about the equal exchanges, and beautiful. And then I just literally moved the decimal to the other side, and and put the decimal in front, and then it was total panic. Yeah. And it's like, wait a minute, we're still operating on units. What are those units? And that was part of the discussion, is that they didn't know the relationship between tenths, hundredths, and thousandths. Because when we go to the left, it goes tens, hundreds, and so they're thinking, well, is the first decimal thousands?
Yeah, it's inverted. It's like.
And so just having that conversation was so powerful. Yeah. And I think, you asked me earlier about the things that I'm proud of. What I'm feeling good about is I also talk in multiplication, about strategies. And there are 3 strategies related on the properties. There's what I call the duplication based on associativity. There is what I call slicing and removing, which are both based on distribution. And so what students have been unlocked, adult learners have been unlocked, that, usually when I'm talking with adult learners, the first question I ask is, can you tell me what 7 times 8 is? And they'll look at me and say, no. And so we start talking about strategies. Well, do you know 5 groups of 8? Oh, yeah, that's 40. Do you know 2 groups of 8? Oh, that's 16. Well, you do know. It's just we need to latch on to what you already know. And so those are things, just hearing some of the stories from this semester's students, that I now understand multiplication for the first time. and I feel empowered. That's the word I keep hearing, is empowered.
Mm-hmm.
And so that excites me.
Yeah. Yeah, and I just appreciate reading it and things clicking into place. Like when you put this thread through there and then it kind of ties things together. That's a good feeling. And that's what math should hopefully be bringing to people.
Yeah.
Math should be this kind of like clicking, things are connecting, things are linking in, but that's not people's experience. Often people's experience is a whole bunch of stuff I have to cram into my brain somehow.
No. Yeah, it's like, I just got to remember all this stuff. And is this where I use the butterfly, or is this...
Oh, yeah, you have a good section on the butterfly.
Yeah.
For the proportions, and just butterfly.
Keep the butterflies out in the world and keep them out of the classroom.
You maybe were a little bit diplomatic because you have several things that you're critical of because they sort of circumvent conceptual understanding. Mm-hmm. But I often noticed you were diplomatic where you didn't totally throw them in the trash bin. You kind of just said, wait, and don't do those until later, until the person kind of understands what they're doing. Is that true? Were you being diplomatic, or do you want to just actually throw them in the trash?
You and I have talked a little bit about this, and I've heard you talk about this too. When we look at the mathematical teaching practices, it talks about the conceptual understanding before the procedural. Mm-hmm. And the idea is that you want to develop the meaning. And when you have the meaning, for example, when I ask my students now, well, why did we use the term common denominator? Why did you get a common denominator? Well, the idea is we need the same size of unit.
Yeah.
We have a language to talk about it now. Mm-hmm. Because in the beginning it was, well, I don't know. That's just what I was told to do.
It's just the rule.
It's just the rule. And it's like even with equivalent fractions, multiplying by the big one or whatever, multiplying the top and bottom by 3. That's not really what's happening.
Yeah.
But down the road, when I was thinking about a geometry problem involving similar triangles. Well, of course, it would be much easier to solve that with the unknowns if we cross-multiplied. Fine. Mm-hmm. And it's something we can use down the road, but there's an algebraic reason for why we can cross-multiply, and we can get into that and talk about that more abstractly.
Mm-hmm. Yeah, well, congrats on the book. I enjoyed reading it. I knew it had come out and I hadn't got around to, so this was a really great excuse to finally go through it. I enjoyed it. There's also just some nice math problems in there that people can do.
I appreciate that.
So, it's great talking to you about it. Let's open up beyond the book. What else are you working on? What else is kind of going on in your world right now?
Well, there are, I just came off being the president of the Missouri Council of Teachers of Mathematics, and we've had a lot of discussion in Missouri. We really feel like we have not, as a state, spent the effort that we should focusing on math. There's been a lot of focus on literacy, and so we really are trying to bridge out and see emulate what Kentucky's doing, what North Carolina's doing. Next month, going with one of your colleagues, Dr. Chuck Munter, to North Carolina to understand what all the great work they've been doing for years. But we'd really like to see a piece of legislature, the Missouri Mathematics Education Act, to where we're putting emphasis and we're building an infrastructure for supporting teachers, professional development, coaching, and just feeling like the teachers. We did a Rooted and Rising Summit in February in Jeff City, where we had 108 teachers that were just fired up to do something different, to really move beyond just end of course testing and all that, but just really develop some cohesiveness to what we're doing in this state. And so I was excited. Not much happened with it this term. But the goal is to continue to
plant
work
the seeds
towards that.
And then find some folks that...
And then working on a parent book around See It, Say It, Symbolize It. Because so many teachers, every parent, one of the struggles with using the reformed curriculum, for example, like illustrative mathematics in elementary classroom, is parents look at it and think it's a new math. Well, it's just getting a different way to think about this idea more conceptually. But every parent wants to help their kid. And so the default is, I'm going to go back to the way I was taught. Mm-hmm. And so the goal is to open it up and give them a deeper understanding of mathematics, with the hope that they'll be more open to giving their own children, letting the teachers in the classroom be more open to trying some of these things that they see as unfamiliar. So those are the two things going on right now. Yeah, well, those would both be great. Keep working at it and see what we can do. Yeah. All right, so I think you've listened to this podcast before. You probably know the final question. Yes. So, and this is from my friend Aaron Brackenecki talking about keeping friends from grad school. Okay. At Michigan State together, he would ask this when we had guests come to campus. And I'm like, that's a good question. So I've been using it for 14 years. Wonderful. But if you weren't in math education as your career, is there something else you could imagine doing, or that you actually thought of doing, or maybe just fantastically would hope of doing? I love World War II history. I could see myself doing a historian. That's on my bucket list to do, is trace the path across Normandy to Germany that my grandfather took 8 years ago. Wow. Just to be able to to get a feel for the land and the experiences and that. So that was one in my mind. The joke was I was going to go into history, but I didn't like to write back then, which is now somewhat humorous.
Yeah.
But the other thing is analytics. I'm a sports freak, so I loved, I could see totally getting into analytics. And back in the days, it was called sabermetrics, but it's gone so far beyond that now.
Yeah.
But those are the things I enjoy.
I can't even keep up with all the stats they have now. Like, there'll be a new stat. I'm like, I've never even heard of that one before. I'll have to look it up. And, like, they've created new, ways of computing.
It's just amazing the level of detail now and what people know about each other and how they interact. And that's all data. We're so quick with data now that sometimes we're overusing it, I think. But that was something back in the day I was, had some interest in.
What are your favorite sports to follow?
Favorite sports are Kansas City Chiefs football, and Royals baseball, which is not so good right now, but really college football and the Chiefs. It's been a good run. I've been a lifelong Chiefs fan. Went through a lot of rough years, but been living the dream in the last 5 or 6.
Oh, yeah. It's been great. We'll have to see if they can still come back around. But, man, the last several years were really fun.
At least they're giving us hope now. There were years of futility. And so, as my wife said, I know you're from Michigan. And so she was a Detroit Lion fan, and they're still hoping.
So when I was a kid, I was a Detroit Lions fan. Still, I'm a Detroit Lions fan big time. But when I was a kid and I was first starting to, tune into the NFL, there was a running back that really impressed me as a young, I don't know how old I was, but Christian Okoye.
Yes.
Nigerian
nightmare.
So I happened to watch a couple games. And I'm like, who is that guy? He's blowing people over, and they couldn't bring him down. I don't know. I might have been 6 years old or something, and I was like, what is happening? This guy's amazing.
Yeah, it's been a good time. It was, like I said, I grew up in the 70s, so it was poverty when it came to the playoffs, and then the 80s, and then the 90s gave us a little bit of hope. And then we went through some, again, more rough times, but then Patrick Mahomes has been the savior of the Kansas City Chiefs, and it's been a fun time.
Yeah, wow. Great to have you here in Missouri. Moving over from Kansas and ended up in Missouri, I think is a good fit.
Yes. Hey, I started out as a Missouri Tiger fan as a kid. So
even living in Kansas.
Full circle moment. Yeah, living in Kansas. I was the anomaly. Growing up 20 minutes from Lawrence, Kansas, and then end up going to the University of Kansas. But I've always had an affinity for Missouri Tigers. So it's a full circle moment here today.
Yeah, well, great to have you on the podcast. Thanks for talking about your work.
Thank you. Thanks. It was a pleasure.